Year 2020 could well be about the sun. In his Mann Ki Baat address on Sunday, Prime Minister Narendra Modi spoke about the ISRO's plans to launch its first sun mission, Aditya L1. This ambitious plan of the Indian Space Research Organization will not only put India in a very elite league, but also at the very frontier of cutting-edge research. With Aditya L1, ISRO will take a huge step forward in the study of solar corona. The solar corona is the outermost part of the sun's atmosphere. It is usually hidden by the bright light of the sun's surface. The 400-kilogram class Aditya L1 will carry 6 scientific payloads that will be inserted in a halo orbit around the Lagrangian point 1 or L1. Incidentally, L1 is 1.5 million kilometers from the Earth. Our focus today will be all about the impending sun mission of ISRO. We will also of solar space and also the journey of ISRO itself. Moon mission in 2019, the space organization is now eyeing to decode the sun. The ISRO is planning to launch an ambitious solar mission, Aditya L1, in the coming year to study the mysteries of the sun. Here are the details. Just months after the successful launch of the ambitious moon mission Chandrayaan-2, India has set its sights on the sun. Indian Space Research Organization will launch its maiden solar mission, Aditya L1, to unravel the mysteries of the celestial body that sustains all life on Earth. Speaking about it in his last Mann Ki Baat program from 2019. For 2019, the Prime Minister said that India is quite advanced in the field of astronomy and ISRO has taken path-breaking initiatives.
सूर्य के बारे में रिसर्च करने के लिए इसरो आदित्य के नाम से एक दूसरा सैटेलाइट भी लॉन्च करने वाला है। खगोल विज्ञान को लेकर चाहे हमारा प्राचीन ज्ञान हो या आधुनिक उपलब्धियां, हमें इन्हें अवश्य समझना चाहिए और उन पर गर्व करना चाहिए। आज हमारे युवा वैज्ञानिकों में न केवल अपने वैज्ञानिक इतिहास को जानने की ललक दिखाई पड़ती है, बल्कि वे एस्ट्रोनॉमी के भविष्य को लेकर भी एक दृढ़ इच्छा शक्ति रखते हैं।
The launch is scheduled for mid next year on board Polar Satellite Launch Vehicle. Conceptualized in January 2008, Aditya L1 mission was originally named Aditya 1. It was initially conceived as a 400-kilo class satellite carrying one payload, a Coronagraph. However, the enhanced Aditya L1 will be carrying 6 payloads. The satellite will be inserted in a halo orbit around the Lagrangian point 1 or L1, that is roughly 1.5 million kilometers away from the Earth. Being placed in L1 position gives the satellite the major advantage of continuously viewing the sun without any eclipses. Originally, the main objective of the Aditya 1 mission was to study the solar corona. However, the Aditya L1 mission now plans to carry out experiments to study other layers of the sun's atmosphere as well. Other than corona, it will also study sun's chromosphere, photosphere, the particle flux emanating from the sun and reaching the L1 orbit.
New name meaning, this name was given somewhere around 2019. This mission was started, this thinking started from 2017. Initially, they thought of a very small satellite, only a 400 kilogram weight satellite to be put on Earth's orbit to study sun. But then when people looked at it, they found that there are very interesting questions of sun. So then the ISRO and the government of India decided that we'll go for a full-scale study of sun, one full-scale space laboratory.
The photosphere is the innermost layer of the sun's atmosphere, about 500 kilometers thick. The photosphere is the source of light and solar flares. The chromosphere is the next layer that emits a reddish glow that can only be seen during a total solar eclipse. The corona is the outermost layer, an aura of plasma that envelops the sun and is visible to the naked eye during a total solar eclipse. It appears as white streamers or plumes of ionized gas that flow outward into space. The sun's corona has a temperature of more than 1,000,000 degrees Kelvin, which is much higher than the solar disk temperature of around 6,000 K.
The solar corona extends up to several thousands of kilometers above the solar disk that we see. And this solar corona, its temperature is 10⁻⁶ degree Kelvin. That means 1,000,000 degrees Kelvin, while the solar disk, which is also called the photosphere, its temperature is only 6,000 degree Kelvin. So it is a big puzzle as to how come the corona, which lies above the solar disk, extended to up to a few thousand kilometers, is so much more hotter than the photosphere, which is only 6,000 degree Kelvin.
How the corona gets heated to such high temperatures is still an unanswered question in solar physics, one that Aditya L1 mission may find an answer to. To study the sun, the Aditya L1 mission will carry 6 payloads, including visible emission line coronagraph to study the diagnostic parameters of solar corona, solar ultraviolet imaging telescope to image solar photosphere and chromosphere in near ultraviolet and measure solar irradiance variations. Aditya Solar Wind Particle Experiment to study the variation of solar wind properties as well as its distribution and spectral characteristics. Plasma analyzer package for Aditya so as to understand the composition of solar wind and its energy distribution.
The coronagraph is a very, very interesting instrument. I mean, if any of you have seen total solar eclipse, when the moon completely covers the disk of sun, then the corona is visible. Okay. Otherwise, corona is not visible. This coronagraph will create artificial eclipse of the sun so that you can see the corona. That is a coronagraph. So it will carry a coronagraph, which will provide us how on real-time basis the corona structures are changing. Okay. Third, the X-ray cameras and ultraviolet rays telescopes in this mission will be able to study the depth of sun, the chromosphere and photosphere. What's happening in chromosphere and photosphere, it will be able to study.
It will also carry a magnetometer to measure the magnitude and nature of the interplanetary magnetic field. The different payloads are being taken care of by multiple institutions, and hence the project provides an opportunity to solar scientists from various institutes to participate in space-based instrumentation and observations. With inputs from Leena Sharma, Bureau Report, RSTV. 2019 has been a busy year for ISRO. It included the launch of a wide array of space probes, missions, and satellites. One of the major ones that kept the nation's eyes focused on space was the Chandrayaan-2 mission. Let us see what were the other significant endeavors of ISRO. Year 2019 was eventful for ISRO with the ambitious Chandrayaan-2 and many other launches. Let's have a look at the major ISRO missions in the year. On January 24, India successfully launched Microsat-R, which is an imaging meant for military purposes, along with student-built nanosatellite Kalamsat from PSLV C-44 in Sriharikota. This is the first mission from the ISRO in 2019. PSLV C-44 was unique in itself, as it was for the first time that ISRO used the last stage of the rocket as a platform to perform experiments in space. India's telecommunication satellite GSAT-31 was successfully launched on February 6, 2019 from Kourou Launch Base, French Guiana by Ariane 5 VA247. GSAT-31 provides continuity to operational services on some of the in-orbit satellites. It also provides Indian mainland and island coverage. EMISAT was successfully placed in its intended sun-synchronous polar orbit by PSLV C-45 on April 1st, 2019. The satellite is intended for electromagnetic spectrum measurement. On 22nd May, India launched RESAT-2B-AA radar imaging Earth observation satellite developed by ISRO. Its launch vehicle was PSLV C-46. Its images will be used in the fields of agriculture, forestry, disaster management. India's geosynchronous satellite launch vehicle, GSLV Mark III, successfully launched Chandrayaan-2 on 22nd July 2019. Chandrayaan-2 was a highly complex mission, which represents a significant technological leap compared to the previous missions of ISRO, with the goal of exploring South Pole of the Moon. It was a successful mission, despite lander Vikram losing contact with ISRO's ground stations back on Earth, as the orbiter continues to relay information to ISRO. On 27th November, ISRO launched Advanced Earth Imaging and Mapping Satellite, Cartosat-3, along with 13 other commercial nanosatellites. Cartosat-3 was launched aboard the PSLV C-47 launch vehicle. It will address the increased user demand for large-scale urban planning, rural resource and infrastructure development, along with coastal land use and land cover.
Chandrayaan-1. Then of course, we followed it by Chandrayaan-2, though there was partial setback on certain aspects of those mission. We reached Mars. There is a plan to send one more mission to Mars. There's a Chandrayaan-3 coming up. People are talking about it already. The Aditya L1 mission is one such mission. The AstroSat, which is a space laboratory that we have launched, multi-wavelength space laboratory we have launched, is performing very well. It's very, very interesting results that no other space satellite have been able to do until now. One of the other, what I would say, the exciting mission of ISRO is the mission to Venus, called Shukrayaan. I mean, at least popularly it's called as Shukrayaan. What is the final name, we don't know.
On December 11, ISRO launched its Earth observation satellite RESAT-2BR1 from Sriharikota. Along with RESAT-2BR1, PSLV C-48 also carried 9 customer satellites, including 1 each from Israel, Italy and Japan, and 6 from USA. Polar Satellite Launch Vehicle achieved a landmark with its 50th mission. The satellite will help in agriculture, mining, forestry and coastal management, soil monitoring, disaster management support, and round-the-clock border surveillance. Bureau Report, Rajya Sabha TV. With this, we'll halt in for a quick break, but we'll be back soon. Stay tuned with us. Welcome back. You're still with us on In Depth. The sun provides energy that allows life to exist on our planet. But we should never forget that its energy comes from incredibly supercharged environment that includes solar flares, coronal mass ejections of charged particles, and the solar wind. Scientists therefore need to understand its behavior and how its radiation affects us. That has been the underlying theme of mankind's efforts to study the sun. Here's a look at some of the prominent missions to the sun. Solar missions have been sent since 1960. These have all had different objectives. Some significant missions that were sent after the turn of the millennium include the Genesis. Sent in 2001 by NASA, it became the first spacecraft to capture a sample of the solar wind. Solar wind is a constant stream of particles that emanate from the sun. After a 3-year mission, Genesis returned to Earth. Unfortunately, it had a hard landing when its parachute didn't deploy. But the samples that did survive allowed researchers to conclude that the Earth was possibly formed from different solar nebula materials than those that created the sun. In June 2010, France launched the sun monitoring satellite Picard. The 143 kilo Picard is based on a microsatellite platform. It was launched by a Russian rocket. The satellite carried 3 instruments: the 11-centimeter diameter SORISM telescope and 2 radiometers to measure solar irradiance. Picard was on a 2-year mission to unravel the mysteries of the sun. In 2018, NASA launched the Parker Solar Probe to dip directly into our star's outer atmosphere, or the corona. The probe was designed to help answer fundamental questions about the solar wind that streams out from the sun, flinging energetic particles across the solar system. It was the first spacecraft to be named after a living person, astrophysicist Eugene Parker, 91, who first described solar wind in 1958.
NASA and Japan has sent something called Stereo A and Stereo B, 2 spacecraft which go around the sun to take study the sun very closely. The other mission that has been sent to sun is the Parker Solar Probe, which actually has gone very, very, very close to sun. In fact, it's going to make orbits in such a way that ultimately it will go and crash on the sun. That's how it will end up.
NASA has sent several missions to study sun, like SOHO. SOHO is one mission which has been studying the heliosphere, sun's atmosphere for some time. But this is going to be the first mission from ISRO to study sun.
The Parker Solar Probe will explore the corona, a region of the sun only seen from Earth when the moon blocks out the sun's bright face during total solar eclipses. Scientists view the corona as the answer to many outstanding questions about the sun's activity and processes. In December 2019, NASA announced the first results from the Parker probe. The spacecraft had provided the closest view of the corona so far. In February 2020, NASA will launch the Solar Orbiter. This is a joint NASA-European Space Agency mission that will address central questions concerning the sun. The Solar Orbiter will address some of the big questions in solar system science. It will help us understand how our star creates and controls the giant bubble of plasma that surrounds the whole solar system and influences planets within it. With inputs from Leena. Bureau Report, Rajya Sabha TV.
Dr. Surabhi, shall we start or other participants joining in? You have to unmute yourself, yeah. We welcome Madam Rekha KR for gracing this very solemn occasion. Very many hearty welcome to you, ma'am, for taking out such precious time from extremely important schedules. And we have a host of schools who would be joining in. We welcome Dr. Sanjay Bhattacharjee from School, Raipur, Chhattisgarh, and a lot of others because they might be just closing their classes. So 11 a.m. Was the stipulated time. So
we have Priyanka ji from Tagore International School, east of Kailash. Priyanka Saraf ji, madam is there. Faculty.
Okay.
Yes,
so
ma'am.
Request you to please turn on your videos so that we can all see you. It's
yeah, kindly switch on the cameras.
If possible, yeah. So I think we can start off, Dr. Surabhi, and let people join
we can start.
so that ma'am had a stipulated timing requirement. So hello and welcome everyone to this very special roundtable, eduROUNDTABLE we call it, on space education on 23rd of August, which has now been named as the National Space Day, India again made a history. We would rather say, in the Rethink India parlance, a reconnection over there, because चांद के साथ नाता तो भारतीय संस्कृति का सदा से बड़ा ही पुराना रहा है. हम लोग बचपन में एक जिंगल सुनते थे कि there is a little bit of sail in everyone's life, there is a little bit of steel in everyone's life. And now our age, after the landing, successful soft landing of Chandrayaan, we can say that there is a little bit of space in each one of our lives. तो भारतीय जीवन में, भारतीय जीवन दर्शन में अंतरिक्ष का, गगन का स्थान सदा से रहा है. बिना ज्योतिषी के, पंचांग के हमारे यहाँ मुहूर्त नहीं निकाले जाते थे. इनफैक्ट there is a hall of fame of Indian astronomers who turned into mathematicians, who were observing the celestial bodies, and the motion of those heavenly bodies, the celestial bodies, made them come out with mathematical observations all through. And all those complex pre-Newtonian era mathematics evolved in this country, of which our eminent institutions are re-excavating them, because there was a brief lull where the Indian knowledge systems were somewhere eclipsed, since we're using the celestial terminology out there. 23rd of August 2023 was certainly quite a day where India's preeminent space organization, the Indian Space Research Organization, was successful in landing, in soft landing. India became the first country to soft land on the south pole of Chandamama. So today we have with us a very, 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 very special, I would say, authority on space sciences, because today's roundtable's mandate, what we felt from the Rethink India space, that we call academia as the fifth estate, as the fifth and the foremost estate, and this will be vital for this coming 25 years of India's collective aspiration to emerge as a Bhavya and Divya Bharat, as a Vikasit Bharat, as we can say. And space is going to play a very, very eminent and a preeminent role. We are thinking a lot about the convergence of technology, the fourth industrial revolution. There's a lot of talk in the consumer-centric space ki bhai electrical, electronics, in computing, information technology are all converging. There is artificial intelligence, but the celestial intelligence, which is still unexplored, I think ISRO has made it possible. And it will be very vital that all the STEM dimensions, what we study right from grade 6th onwards, there is an extrapolation of the entire STEM subjects, the science, technology, engineering, mathematics, and if we can even put STEAM, the arts part of it, it all converges into space. And if we can somehow, I would say, enthuse our students at large to become space students. At Rethink India, we have chosen to commemorate for the first time the word is Space Week, which happens from 4th to 10th of October. And we would be having a range of engagement activities as a part of becoming a space students. Students from class 6 to 12th would be most welcome to participate in one or more of these engagements. The first one is like watch any of the popular motion pictures based on space, be it Interstellar, be it Gravity, be it any popular motion picture or a web series, and present to us, to a jury. Get fascinated about space. Just learn it from a popular culture, because that is the first step to really deep dive back into your STEM textbooks, into your science books, as to how this projectile is further improvised to really make a Vikram lander land at the moon. The second activity which we have curated out here is like how you can assess your space question. We would be giving you a set of some 8-9 deep videos on space, explaining the nuances out there. Video is a very strong medium these days. And then based on those videos, those docu-series, you appear in a kind of a test and assess your space quotient. Now, spiritual quotient, there is something called space quotient. Now it's in the vogue. So let's celebrate the space quotient going forward. The third activity which we felt like curating is demonstrate a space application, be it Google Earth, what kind of a project, how you can make a KML file or a Navik-based GPS system, or any other space application which you feel you demonstrated to a live jury. So that is your hands-on functionality, hands-on rendezvous with space, we can say that. The fourth activity which we feel is that the success on 23rd of August, and we can see, we all watched those live relay videos when ISRO chairperson S. Somnath sir was standing on the dais, and he did not stand alone. He brought his entire team together, and if you see the cameras roving in that Chandrayaan Mission Control Center, you can see the kind of jubilation, the combined jubilation. It was a collective success of hundreds and hundreds of scientists. Only a handful of them can come on the stage, but each one of them were cognizant of the support which was given by the others. So ye jo collective leadership which ISRO has shown since inception. ISRO has a wide network of laboratories, wide network of centers. So the first level, if you really want to aspire towards becoming a kind of a space scientist or something else as well, in the whole continuum, a space engineer, even an astronaut for that matter, because now Gaganyaan is on the anvil and more space missions would be out there, what we watch in Star Wars and popular fiction. So plot the ISRO universe, go to the ISRO website, cull out as to what creates this mesmerizing network of institutions which has made this feat possible. It is not a solitary effort. It is a collective effort over decades and decades, and stridden with failure, because every failure, it brought about new learnings, new insights to the eventual success. And success is not final and failure is not fatal, as we all say. So illustrate the ISRO universe through a mind map or any kind of a presentation. That's a challenge which we want to throw to the prospective space students. Mind map the Chandrayaan-3 technologies. ISRO has a lovely full page on the advanced technologies with Chandrayaan, the rover, the lander, they are all stuffed with. So can we map these advanced technologies somehow with whatever our existing knowledge is, with our current, I would say, STEAM index, with our current at the K-12 level PCMB index, we can map it somehow or the other, because space sciences, space technologies, space engineering is obviously exponentially ahead of what we are studying in our school classrooms, but at least it can give us an imagination. It can give us that leapfrogging. Oh, if I'm understanding this projectile, this is what goes on, and how the projectile functions in that slingshot movement, and how the atmospheric pressure varies, how all kind of sciences which we study, we can incorporate it across. So that is another kind of an activity which we put it across. And these are all mapped to the days. We are saying that each days the juries will be sitting on, and today is the kickstart of this the commemoration of the Space Week from 4th to 10th October, which we will be having. And the sixth activity is like explain the career pathways in space. Make your own research, go back, create your own understanding about the various career pathways in space. Not everyone would be becoming a Neil Armstrong or a Rakesh Sharma or everyone else, but it's a collective effort. So in the whole continuum of space, in the entire space compact, what role can you have? And to explain this entire sextet, we have this very eminent personality. जैसे बचपन में माँ हमको हमारे मामा से परिचय कराती हैं, and ISRO is really very endowed with the Matra Shakti of Bharat, and we saw that jubilation कि tradition meets technology, कि यह भारत का ही अधिष्ठान है, कि जहाँ पे परंपरा और progress, it goes hand in hand. And today we really welcome a host of our school principals who have joined us. Dr. Surbi, I would be giving you an opportunity to welcome them all. And these 6 dimensions we felt would really commemorate, we really help us get engaged, because emotional sentimentalism is all out there. And a lot of superficial chatter is happening about space, but a really deep dive engagement. This is what we feel should be there at Rethink India. And maybe this activity, this set of activities, this whole energization, it really takes us to really inspire a host of our young students who can really become contribute to India's space journey, the global space advancement in times to come. We initiated on the birth anniversary of, we can say, the founder of India's space program, Dr. Vikram Sarabhai. Rethink India created a kind of a WhatsApp group, which has become a kind of the de facto way of collecting people, a Vikram Sarabhai Space Club. We are inviting this schools at large to establish their own local chapters of Vikram Sarabhai Space Club, create a small space, jot down what kind of posters or pamphlets or books from library, create a kind of a space to host this space club and enthuse the interested ones to really remain engaged with a host of space activities, and as a first step, join that WhatsApp group so that Rethink India can keep on giving you pointers and inputs and a host of other things. We, on the Punyatithi of Neil Alden Armstrong, the first man, because now India is slated to launch its Gaganyaan mission as well, the first man mission to moon. So in his recognition, what kind of I would say qualifications are needed to become an astronaut? Because wo kehte hain na ki who is the end hero of it all? The protagonist, the person who really lands up, the astronauts. So that is another activity, that is another space we felt the students should be engaged in. So the entire idea of this whole engagement is converging the entire spectrum of STEAM education on our schools, extrapolating it across to the dimensions of space, to those astronomical distances as we measure distance in the space in light years. So something of that order, which we really want to have it. I would now request Dr. Surbhi to welcome our guest, our eminent guest, our person who would be introducing us, giving us the first peep into the mesmerizing universe of ISRO, Madam Rekha KR, who happens to be the Deputy Project Director at the Liquid Propulsion System Center. एक बात मैं और यहाँ कहना चाहता हूँ कि साइंस और टेक्नोलॉजी की जो फील्ड है, it's very complex, it's very involved. And somehow in today's time, when the popular culture, everything is reducing into abbreviations, everything is becoming an instant gratification. I think this is an antithesis. Becoming a scientist is all about perseverance, it's all about endurance. It is all about a long haul vision and commitment to fulfill that vision. I think that giant leap which we have to take further and forward. These are some of the values which we can probably instill into the students if they really aspire to become those space students out there. Over to Dr. Surbhi to formally introduce Madam Rekha KR, and without any further ado, we request Madam to give her address, preside over today's roundtable, and post that we would invite our honorable principal ma'ams, sirs, and also some of the handful students who have also joined in to ask some of their questions from Madam Rekha KR, and we take it forward. Dr. Surbhi.
So we are really privileged to welcome Madam Rekha KR, Honorable Deputy Project Director, Liquid Propulsion System Center, ISRO, to the Edu Roundtable on Space Education. And to briefly talk about Madam's prolific journey. Madam has been is a BTech and an MTech from the TKM Engineering College, Kollam, Kerala, and College of Engineering, Trivandrum, Kerala, and has worked in the field of mechanical design and finite element analysis for different ongoing projects of ISRO like PSLV, GSLV, and GSLV MK3. And from July 2018, ma'am has been a Deputy Project Director responsible for the development of the indigenous semi-cryogenic state systems. Madam has received the ISRO Team Excellence Award 2014 for indigenous cryo stage for GSLV D5 mission. And Madam is so very kind and has graced this occasion, and been Madam will guide us about the space education, how we can take forward this mission of, we are celebrating the Space Week from 4th to 10th October with our schools, and how at the school level we can, really instill these values and scintillate the students with the elements of space vision, space education. We are joined by Madam Ira Vishwakarma from Vidya Bharati School. We are joined by Sanjoy Bhattacharjee sir from School, Raipur. We are joined by Anuradha Monga ma'am from Bangalore International School, Bangalore. And we are joined by Priyanka ji from Tagore International School, east of Kailash. And welcoming all the faculty coordinators.
Sorry to interrupt you all. I am Priyanka from Vidya Bharati School.
Okay, you're from Vidya Bharati School. Okay, great, lovely, nice. Welcoming you, ma'am. Welcoming Tulika Joshi, ma'am. Welcoming Ravinder Kaur Saini, ma'am. Ritu Noria, ma'am. And our distinguished guests who are all watching us on YouTube live. So welcome you to the Edu Roundtable on Space Education. Over to Raghav.
So over to Madam Rekha KR for her address today. And one secret question that as to how the Matra Shakti really empowers these gigantic missions across. There is a kind of a misnomers all across, but women, the Stri Shakti is leading it all. Madam was the recipient of Srimati Sushma Swaraj Stri Shakti Samman a couple of years back from Rethink India. So that is what the power of Matra Shakti ki parampara or progress, the modernity, they are interlinking the most modern, I would say, technological spaces they are leading across. So over to Madam Rekha KR for her address.
Thank you, sir. Thank you, ma'am, for the nice introduction. I am really very happy and thank the organizers for this great opportunity so that I represent ISRO to you all. Then as it's a very exciting and very, interesting introduction Raghav Mittal sir has given already. And I congratulate Dr. Surabhi ma'am and your team for the earnest and untiring efforts you are taking towards the Atmanirbhar Bharat. You constantly inspire people. You take you work like an interface between the people, and you bring all people from various phases together into a common forum, and you make them interact, and all people benefit out of that. So this is not a small thing, and I really congratulate your team. And of course, I shall express my utmost respect to each of the participants who mold the future generation of India, and I am happy to be with you all. Anyway, even though the number is less, I am not disappointed. The people, those who are really interested and those who want to inspire the young blood are here. So congratulations to you as well. And about me already, madam has told, I am working as deputy project director, and I have been into this design and analysis business for past 19 years. And after that, I have moved on to project, and I am lucky enough to touch different areas where the space program is linked to. And of course, I must say, unlike before, ISRO and its missions are very popular and interesting to public now. And okay, sir was in the introduction, sir was telling that they are planning so many fascinating things for the World Space Week celebrations. So I think this year it is going to be a mega event. That is from October 4th to October 10th. We are going to see various programs all over India, I am sure. And the projects or the plan, what he has told is really good. That is motion picture, then web series regarding this space themes. Then I think some success on 23rd, how to narrate that. And of course, some fascinating projects so that people can build up and they can present to. So the same thing only, I think a few suggestions, out of the few suggestions I wanted to tell you, all these things includes. So you have taken an early plan for this, ma'am. That is one point I would like to appreciate. And another point, the head of the institutions that you have invited for this talk, that is another big point, because normally for such interactions, students will be called, and the students know it is good only. Definitely we'll be conveying ideas, we'll be inspiring them and all, but they need constant support, and they must get inspired through the teachers they directly deal with, and they need help from faculties for forming up the club, for their activities, all those things. So primarily the head of the institution or the faculty with a flavor of this scientific activities must be guided properly. Especially they may be having, or they may have interest, they may be having knowledge, acquired knowledge through different media, all those things, but we must expose, or we must tell them what are all the facilities available through which they can approach, and we can enable our students for doing their all this what is that, maybe like R&D kind of thing. They can make projects like they can, what is that, some what is it, hackathon kind of competitions they can participate. They can there are so many programs ISRO is offering. I think the year-round ISRO official, I mean our engineers are working on that. And there is every center, there are HRDs and contact points are there. So I shall come to that after a brief overview about ISRO space program. Though you know all these things, I think you're all senior people, head of the institutions, and definitely you must be knowing about the Indian space program and all, and including our future missions like Aditya L1 and all. Rekha sir has already that we have seen some trailers just before the beginning of this meeting, and I'm happy to see all that, because public is much more aware than many around, I think. Now I shall move to my brief introduction, I mean like the overview about the ISRO missions and programs. So I shall try to share my screen. I hope it is visible to everyone.
Very nice.
Yeah, ma'am.
Yeah. Okay. So these are all elementary things, like why it is too peripheral, I must say. That is for a few reasons, because this is majority of the information is available in ISRO website, even more than this, and you can and there are limitations to share the sensitive information as well. I'm sorry. And here you would have seen these photographs are very familiar to all people, and this shows the humble beginning of our ISRO space program, started in Tumpa, that is in Thiruvananthapuram, the capital city of Kerala. And in 1963, we started the space program. That was the beginning with the sounding rocket. And later SLV-3, and you know the journey was passing through this in 2013, our Mangalyaan Mars Orbiter mission. Then now we are after Chandrayaan-3, I think ISRO could make the nation proud, and you were also, each Indian was celebrating that, and it is not the part of ISRO, it's ISRO alone. Of course, every way, somehow or other, each citizen is involved in that. At least I must say, the people around us always encourage us after each mission accomplishment, and so we consider each of them. That is really very valuable, and that inspires us always. So they are all part of us. Okay, ma'am, then I shall pass on to, so there are many centers in India, so you can just see this, and see every center, you know, basically we are into this launch vehicle and satellite business. Different centers are there for making this R&D programs are going on. This making of this launch vehicles, satellites, its applications, all those things are there, and these are all available in net. And you can see SLV and ASLV are not operational right now, and PSLV, GSLV, and GSLV Mark 3 and recently SSLV also, they are all the operational vehicles, and the R&D is going on much more. Then the major elements in a rocket system, as you all know, there are different parts for this. Basically, why I am representing this slide, because it is not a very complex thing or something just like that. And almost all the engineering topics, science, physics, chemistry, everything is involved in that. Space science is not a very isolated area or a very specific thing. So it includes almost all the subjects. So you can just see this structures. Basically, this is the containers for that or the shell, which carries all these payloads and other things. And that includes, basically, we go for everywhere, this design, analysis, simulations, testing, all these things are there. For that, the infrastructure we are making, and the different experts or the people which is having expertise in every field are dealing with all these activities. So structures means that is material is there, then design is there, then fabrication is there, different fabrication technology. You know that we are now much away from conventional fabrication technology to advanced, that is additive manufacturing. So every front, there are revolutionary changes in the field of materials, you know. Then next is the avionics part, then the control and guidance, computers, telemetry, tracking, then pyros, then this propulsion is the basic physics, while the propellants are the chemicals. So these are all areas where students can invest their time, like Rakhav sir was telling in the beginning. STEM or STEAM, every time, see everything, basic sciences, see astronomy also, NARL, PRL and all, they are doing a lot of studies in this astronomy, and even for Chandrayaan-3, lot of experiments were done in those centers. So that is one way. Then next is our, see this, there and all the research and all is there, the work itself is a PhD topic in PRL and all. So people after taking this BSc degree in physics and all, they can join for their research studies there. Then in the people or the professionals in different science and technology field can have training in centers like IISR. So a lot of opportunities are there. And if people, I think our head of the institutions, if they go through ISRO website itself, lot of informations are available. So kindly, my request is, you are the people, those who are passing on this, what is that, lamp, or the spark within the students can be brightened through you people. So please do that. And always ISRO and our people are always there to support you. And the one thing I am really happy is, today's attendance itself shows that I think the interest that came from that, I'm sorry to tell that, but the people, those who have come, are genuinely interested in that. That matters. So we don't run after I mean, what is the cloud of people or the crowd of people. And I think through the genuinely interested people, we can approach, and that we can find out students of scientific temper. I am telling that this is not only through space. We can definitely other than space also, there are different fields like medicine, then there's so many things like this, so maybe water technology, or for day-to-day life, what all we need, everything. So many other fields are there in science and technology. So from those fields also, people can emerge and take initiative to bring out the children, those who are really interested in, or those who are of scientific temperament, I say. So this could be done. Then why space? If you are asking me, space always fascinated people and our children. No, like still I am when an aeroplane goes or rocket goes, just like the enthusiasm in a kid always work in every human being, irrespective whether it's a kid or a grown up. So we always, and human always like mystery. So this is a very good what is that, a field through which we can enter the mind of students and they will get inspired. That doesn't mean that they should work in space, in the sense that the person need not work in ISRO for becoming, what is that, for appreciating all these things. It can be, he can even work in industries. There are a lot of industries supporting ISRO program, as you know, L&D, then Godrej, then Midani, so many big industries and small industries also as well. So they are all making in the field of helping us in the field of fabrication, materials, so many other things. So they can become a part of industry also and become the part of the space program. And they can R&D, different our academia, IAST is one institution where exclusively that is with affiliated to our DOS only. So there people study more about space program, and apart from that, IAC, IIT, and all, so many MOUs are there. So we are some research works are going on there. So every way, academia is involved, industry is involved, small, big industries are involved. Then what is that? Our ISRO, our R&D institutions, then science and technology. So this is an interlinked one, and the scope is tremendous. So this message should go to our children, and they should know that it is rocket technology is not always very complex, and it is all based on basic fundamentals. And from based on their interest, they can build up. This is what I wanted.
Madam has really simplified the colloquial moniker. It's not a rocket science. So the rocket science is as easy as Madam Rekha KR has mentioned. So I think that moniker would go away, that, okay, yes, rocket science can also be championed. And what we were also suggesting and submitting, that all chapters and concepts we have in the 6th to 12th sciences, mathematics, all subjects, they all converge out here. That is the beauty of a single, I would say, a space system, what Madam has explained so very beautifully well, ma'am. Please, please.
Thank you, sir. So as you well said, in fact, this basic science itself, in our, specifically we have site, you know, there are site like Bhuvan students, then Yuvika, all these things are there. So there you can go and see how we are encouraging the people, those who, or encouraging the students which are genuinely interested in. So, you know, I will come to that later. So I shall move to next slide. Now, similar to our launch vehicle, I have told we are into this business of launch vehicle and satellite, and these are the power system is there. And basically the one major difference with the satellite is this power. We are through solar panels, we are recharging our batteries, and there is no power in space. That is one major thing. And other than that, you know, the payloads can be even satellite and our Pragyan and other experimental modules, then avionics, structure, propulsion, all those things. So then the satellite may drift from its orbit, and for keeping that in orbit, we are using this spacecraft attitude orbit control, and for that we may require thrusters, small thrusters as well. So all these things, you know, I am not elaborating all those things. And of course, you know what our Indian satellite Saga, that is Aryabhatta, starting from Aryabhatta, Bhaskara and all. Now we are purely indigenous satellites we are making, and you know even better than me what are all the payloads. Now, basically, we are into this remote sensing, communication, navigation. Of course, you would have heard of NAVIC. NAVIC is anyway limited applications are there for the GPS. Then scientific missions like interplanetary missions and all. Then futuristic applications, all those things are there. And basically, this remote sensing applications, so that brings a lot of benefits to public. So under meteorology, I must say this weather forecasting, disaster warning, climate change studies, ocean studies, atmospheric studies, all those things, because in every field people are working in sync with this, and they are making use of this data. If you take this agriculture, this vegetation cover, then crop inventory, soil assessment, drought monitoring, geological testing and other things. These are all it is known to you all. Okay, so even this, what is that, rural area people are making use of this data right now. And I think in my childhood, I used to see every year there will be refugees coming to our places after flood. It was a very touching. See, even without food for a couple of months or a couple of weeks, you should see their children, the way they ask us. They are also human beings, and it was a very touching scene that I have seen in my childhood. And now I think this is one major achievement, like only few people die out of this and all. So early warnings definitely help people. And this soil assessment, and of course this mapping road and highways, this transportation, then the land survey, we can make how much of the deforestation happened, and plantation we can plan, then water resources, fishing, mineral and oil resources. These are all very old thing. Over a decade we are after all these things. I need not tell you all this. Then spin-offs are there. That is just like petroleum, we are getting byproducts. When we develop our rocket technology, there are other byproducts or definitely other uses we are doing. So this border security, this military intelligence in the field of market prediction, then economy planning, humanitarian. So these things help our people in that way also. So this is the site what I told Bhuvan, that is gateway to this. All this remote sensing data is uploaded in this. Anybody can visit the site and you can get all this. And for this student, I told this school Bhuvan is there. It's a portal providing map-based learning to bring awareness among the students. That is based on the digital data, students can make mapping. Nowadays, when during schooling, typical map will be given and we'll be just copying that. It will be really interesting to students if based on the data, if they are able to make maps. So these are all examples, like you can just see the political, agricultural, water, then soil, all these things they can create by themselves. So definitely this will be interesting. You can just encourage them. And anyway, other applications, if I say, this space telescopes and all, that is we can just like putting a peg on a moon or somewhere in ISS or somewhere, and using telescopes you can just study distant objects. Then space tourism is a very recent thing you are all hearing. Then space stations, that is bigger, and we are all planning for this bigger and advanced space stations for exploring further space. Then protecting Earth from asteroids, of course, that we are supposed to the debris, and one recently in we have opened, I think you would have seen, inaugurated for this debris study, one in ISRO, one unit is open. Then satellite constellations, like for the communications and all, or SSLV and all, just like a small satellite and all are aimed, or that is meant for such purposes, in fact. Then lunar and Martian gateways, all those things you can see. Now, spin-off technologies, already I have told you, these are small examples. I am not going deep into that. The silica aerogels, then fuel cells, batteries, lithium-ion cells, then this microprocessor controlled litany and all this biological applications, all those, many are there. That it's all available in internet stuff. Now, another important thing, ISRO, other than its routine space program, we are supporting startups as well. So the private agencies, you all know about InSpace and all. InSpace is the interface which is working between ISRO and the non-governmental space agencies. And these non-governmental space agencies, see, there's Vikram, Skyroot, Acnicul and all their recent missions and all, they are aiming small payloads right now, and gradually they will build up, hopefully. And government is also supporting them, and that is why this InSpace, it's a government agency, and through it works as an interface for this guidance for utilizing our facilities, and for this what is that the making in the process. Okay, now so these are the basic things what we do. So only a peripheral, very general idea which you all know, and I invite you people, that is every center, one HRD center is there. The contact details are available in the site. Almost 14 centers, I think HRD contact points are there. You can always contact the HRD focal point, and one invite from the school is enough, I must say. So we are there to help you. There are a lot of public outreach program, and through offline, I mean online as well as offline, people visit, that is ISRO engineers or other senior faculties visit the center. They deliver lectures, especially during World Space Week on, that is October 4th to 10th. In that full week, dedicatedly our engineers go to different schools. We conduct program like with respect to the theme of the World Space Week, we deliver lectures. Then we conduct programs. See, as sir told, STEAM, it can be related to science, technology, engineering, arts, mathematics, anything it can be. So arts in the sense, a person or a student which he neatly paints, or he is talented in painting or sketching, he can bring his concept through that. Anyway, see, a linguist, he can, I think, who is an expert in English or any other language, he can narrate very good stories to students and they can inspire him. So everywhere scope is there. Everywhere scope is there. So we conduct space quiz, we conduct elocution, we conduct this painting competitions, debates, all those things we conduct as part of this World Space program, and also year round. And you know, we are all busy with our hectic schedules, but still people are really interested to do this. Really interested to do this. I know a group of young people, young engineers, those who are voluntarily doing activities in Science and Technology Museum, especially during summer camps. They invite students from schools, those who are really interested in this astronomy, and they take classes for them, and they bring their own telescopes and binoculars and all these equipments, and show them how all these galaxies look like. And anyway, with great effort, Science and Technology and all, they brought so much, I think, many equipments for students and all. So a lot of initiatives people are taking. Even in planetarium, they come, and if nobody is there, how children will be guided? This is what I am telling, that the faculty can be the school principal or a senior faculty, those who are genuinely interested in. I know many teachers, they write articles in YouTube, you know as well. So Rekha sir, he was telling a lot about space, and I am really very happy. You can, I think you people, I think that Rethink India can do wonders if you stand like an interface. Around the city, there are a lot of people, those who can, like the facility wise, they may be really good. The school may have required level of infrastructure, that is projector may be there, computer may be there, everything may be available to them. Big conference halls may be there, and for exhibition they may have space. But a rural area, you please think about it. If one staff member who is having a mobile and a monitor himself can definitely inspire the people. This is what I see. Definitely. And out of 100, 2 or 3 may be there. They are going to be the stars. There is no doubt, because there is spark in them within. So I think, ma'am, sir, definitely you may be able to do a lot for these children. And children are the people, those who respond the maximum when we are conducting such events and all. You should see the interest they take during World Space Week program. And unfortunately, now only we are expanding our, areas, like it is this side. Anyway, from different centers, it is always there. But from our side, anyway, for this Pearl Jubilee celebrations and all in our center during that time, we have visited all over India, almost like Shillong, wherever ISRO centers were there, keeping that as nodal point. Lot of activities were done. If schools or a team like you are taking genuine interest and you see that things can happen, I think we can do much more, definitely.
Truly.
Yeah.
Maybe we could take some comments and questions or concerns or challenges what our school principals face, and maybe I would request Madam Ira Vishwakarma to come first, and then others I would invite Madam Ira Vishwakarma, ma'am. Okay, maybe she would be joining in. Dr. Sanjay Bhattacharya sir, who comes from Chhattisgarh, MM School, Raipur. So, Dr. Bhattacharya.
Good morning, Rekha ma'am, Raghav sir, Surbhi ma'am, and all the eminent participants in this program. First of all, I would like to congratulate ISRO and Rekha ma'am for that amazing achievement on 23rd. It was really, really one of the best.
Thank you.
And we all Indians, we felt proud because of that extreme achievement. And Rekha ma'am, Surbhi ma'am and Raghav sir, I congratulate you for giving us this opportunity to be a part of this program. Rekha ma'am, I want to ask one question.
Yeah.
Space education is one of the most important part in 21st century education platform. But still, in school education system, it is not exposed properly. It is still limited to project or visiting the ISRO center or this kind of things, but it was never introduced in the mainstream learning. So what is your recommendation and suggestion to introduce space education in school education system? Can that be a part of integrated learning in social education or social studies? So can you please lighten up for this situation?
Yes, sir. So I shall tell you, my view is basic science like physics, chemistry, and other sciences, definitely they are children. So the basic education is a must for them. And the curriculum accordingly, what you are made is really good. And of course, as time changes, we make changes in our curriculum as well. And you can include that is the current technologies and all. Right now, we have seen that the text what I have learned in my school days is not the text what our students are learning right now. Apart from that, that is you can in a smaller way, like as an introduction, you can just introduce it as a chapter and all. It is already there, I think. What I would prefer is there are debate clubs, sports club, arts club, and all in your schools. You can, why don't you think of a space or a aerospace club in your school? So this will be definitely good. What I'm telling is you start from small things, like ask them to make some what is that, some PPT presentations on specific topics or something like that, and build upon that. And the annual, you can make an annual report. You be the nodal point, sir. You be the nodal point, and the articles and whatever contributions they are making, you please enable them to make it like a magazine or an annual report. You can send it to our ISRO headquarters. So if people, I think the children are taking interest, definitely it will be reciprocated. Mm-hmm. I have even discussed this matter with our HRD people as well. So what we can do for children, this is really, really good. And the activities that you are doing as a report, if it as from the nodal, as through a faculty, if we reach, it is easy for the people from our side to contact you, and it is directly to children means it may not be possible. If somebody is taking genuine interest, and if it comes to a common platform, like ma'am, what she is doing right now. So if it comes to a common platform, it will be very easy. Sir was telling that he has created a WhatsApp group. So all this information will be available in the WhatsApp group. And at times you can have online meetings, and these informations can be, or if you need a discussion, even ISRO people can also participate. Those things is possible. Right now also online classes and other things are there. So majorly these messages and the facilities are not reaching people or the school, the faculties of the school or principals or the head. I am telling you, see, if I'm calling 50 students for this discussion, that limits to that 50 students. They may get inspired, but one head of the school or the principal of the school is well aware of all these things, the facilities, if he is genuinely interested in these matters, he is interacting with maybe 1,000 or 1,500 students. And you can inspire them, being their favorite teacher, you can inspire them more than external people. You can make it simple to them. You can always tell them rocket science is not a complex thing. It is always based on simple things. Basic science, engineering, technology, basic science itself is good. See, a lot of students, they are inspired by astronomy. Through astronomy only, people are getting attracted to space and other things. There only I told our people, they are taking selfless efforts for inspiring people through the Science and Technology Museum and all. They take classes for them. If somebody is doing the same for them, definitely, I think Rethink India can do this. They can arrange people, and through them, people can come to different centers and all. So, such clubs and the club activities are, I think, that will be definitely, the STEAM activities definitely can be done. It need not be space always. Mathematics, it can be art, the creativity, everything.
Thank you, ma'am, for your suggestions.
Thank you, sir.
Your points are noted, and definitely we'll be implementing in our school. And we will be updating Rethink platform in that workshop group about with the pictures and the PPT presentation, the model making, and we will get back to you. Thank you, ma'am. Thank you so much.
One more point. I wanted to add one point. See,
Yes,
headquarters, if you headquarters that details are available inside, if you contact the people, lot of materials are there. You can inspire them by showing these materials. Videos are there, then presentations are there, lot of materials are there. Please try to get all those things.
Sure, ma'am. The headquarters, definitely we will be looking into that websites, and we will be uploading that in that same portal as well. Thank you, ma'am. Raghav sir, you were about to say something.
Yeah, I was just saying, like, as a I would say layman user of all this space technologies, one very exciting thing which can really enthuse the students at large is like go to the Bhuvan portal of ISRO or and try to locate your own house over there. If not Bhuvan, try to locate your school over there. Because see, it's a convergence of all technologies. In the computer laboratory,
Definitely.
the geographical teacher can say that what are the latitudes and longitudes of your school. Even if people have smartphones, use the location feature and latitude and longitude which is coming over there. Now, many of the platforms are graduating to the NAVIC structure. After the US one, but at least the latitude and longitude will inspire them. Oh, this is the first step, what we have it. So space application, we can start with that. This space imagery is so fascinating. We can use, probably it's a much advanced platform, the Google Earth for that matter. The whole school boundary, if it can be plotted, if the whole city can be plotted, we all come from very remote, so-called hinterland towns of the country. 672 plus districts we have, not from the metros per se. Locate yourself over there from the space. We can watch it like that. We can enthuse the students to watch space movies. We all want to watch movies. So why not we cull out a list? Rethink India, we have decided to celebrate every Saturday as a space Saturday. So every Friday, like a blockbuster when it gets released. So we will try to host. We are getting the information from Dr. Surabhi that being a Monday morning, somehow we targeted it where we said it's Chandra, so let us do it at Monday, Somvar. But somehow Monday morning, start of the week, many of our principals were struggling with their weekly course and they could not join in. They are sending apologies across. There were 50 odd principals from across the country they were to join. So Saturday is a great day where we can fascinate the students. So whatever they go back, there is a lot of popular culture around space. And that is what we want to celebrate as a part of the Space Week. That starting from today, 28th of August, the whole month is out there. Watch a lot of space movies, fiction movies also, because they take your imagination to a different level. Then watch docu-series, because any fiction movie will not be based on, has to be based on the space principles only. And then we can involve them, engage them in a host of activities. And that is what for We, in the honor of Vikram Sarabhai sir, Vikram Sarabhai Space Club, we can just start that function, and every Saturday we would be announcing the timelines where we will be having I would say these engagements. And one small thing what madam said, the whole ISRO universe print that out of 14 centers have got HRD over there. So wherever we have a nearest space center, at least a Tirth Yatra to that space, ISRO space center can be scheduled. If there is a problem, we can try, we can use our good offices to reach out as well. So बच्चों की एक तीर्थ यात्रा ऐसे space centers में जाना प्रारंभ हो. Like in 1998-99, when we had the National Technology Day, India became a full nuclear power. And today in 2023, we have declared that, oh, we are the big boys in the space club. Now you will not tease us, or we have arrived to the space club. So I think huge things are there, and small, like geography can be taught entirely from the space imagery perspective. When you are talking estuary, any of the specialized features, use a Google Earth out there. Now we have 3D visualizations. So we have to fall in love with space in real classroom teacher, science classes, even biology classes. What kind of extraterrestrial animals, what kind of their classifications out there. What madam has said, it's a convergence of esteem. The beautiful Chandrayaan logo, I would say, can our good graphic designers design it across?
Yes,
so every domain of human endeavor is really converging out there. And Prime Minister has launched a beautiful hackathon. You would be receiving our ancient wisdom, our astronomical wisdom, what we used to have. Can we derive their scientific validations to the future? So this 23rd August has really integrated India's past with India's future. It's quite a kind of a, I would say, inflection point out there. So this was a small suggestion, and this today's roundtable is just a start of a grand beginning in some way or the other. Like, let's fall in love. Like in 19, there was a space war. India may constructive, we have a thought. We don't believe we will have space wars or we will dominate over others. We have so much of constructive utilizations. Today we see the kind of fury in Himachal Pradesh and Uttarakhand. All the states are now working. Their government is now waking up to use satellite imagery to regulate the haphazard construction which is coming out there. Space has given us that power that you don't have to survey each and every micromillimeter. The space imagery live from ISRO, the cartosats and all, they can give you time sequential studies. So that kind of applications. And I tell you from my personal experience, we gave a challenge to the students. I worked for the water bodies in Braj region, and we threw a challenge for the, I would say 9-10 graders to use Google Earth and spot the water bodies across. Today, Ministry of Water Resources has come up with a huge satellite data which maps with the conventional wisdom that there are 25 lakh water bodies in the country. So can we do a district level geographical study wherever we are residing? Those kind of practical applications can really come in play. And madam has simplified rocket technology audaciously well. It's not a complicated science. I think that this roundtable will be remembered for. I think Dr. Subbi, someone had a question again. Please.
Yeah, I think we have a question from Tulika Joshi, ma'am. She's from Tagore International School, Vasant Vihar, New Delhi.
Yeah. Please.
Welcome, ma'am. Please.
Hi, good afternoon. Good afternoon, teachers and Rekha ma'am. Congratulations, Rekha ma'am, for the successful this project of Chandrayaan 3.
As well.
Ma'am, I'm from Tagore International, Vasant Vihar, New Delhi. And in our school, there is already an astronomy club. We are running an astronomy club. Many students are part of this club. And they have been to ISRO also last year to see what all projects our scientists are involved in, just to have a look. And previously, I think before COVID, students were there at NASA, many of our students.
Very good.
So we usually organize such type of trips. Ma'am, my question is, in Delhi itself, how can we arrange a trip or the nearest place so that students can at least have a small gist of whatever is happening or what all new is happening in the field of space science?
That you mean to say that is in between sometimes the voice was breaking. So I think what is actually you are aiming for? It is a space quiz or lecture or something like that?
Yeah, ma'am.
We're talking about the space visit.
I told in the beginning, one invite from the schools is enough. So we should plan for it. Huh? Okay. That is one point. Secondly, for really to inspire them more, we can always give them tasks. Let them start with the water rockets or something just like that. Always give some task. Unless there is some target, they will not be interested. So we have to see. We must concentrate their attention towards what they are doing. This is where I think the faculty or teachers can do better. So the missing link, that is what they do and what way they can be inspired. So when they are making something like some constructing something, some object space related something, some project, if they are doing, what way you can support, where the components will be available, how you can do that, what is the easiest way, what is the easiest way of approach. All those things a senior person can of course guide. I think Tulika ma'am, definitely you people will be doing that. That is why you, and Yuvika is another site you can just visit in. Yuvika is the program. I think in my presentation I included that. So it is a training program for 2 weeks, and students will be based on their academic profile as well as from their extracurricular activities. These people will be selected. I think last year we got more than 150,000 applications, and out of that 150 students were selected. Every year it is there now. I think for the past 3-4 years it is there. And the students will be staying here. Eminent personalities will be taking classes for them. Hands-on programs will be there, projects and facility visits, all those things are there. So Yuvika program, you can just encourage them for this. And even they will have, or they can have an interview with our chairman ISRO. So this and all will definitely fascinate students. Please do more.
Mm-hmm.
And I'm just reminded that when we were in school, I hail from the DPS RK Puram, we had a visit to the Nehru Planetarium. You know, this is the must watch, the planetarium show. I hope we have already done that. And gazing the stars, and it's a recorded show, but then at least that's the first stage of initiation. It is really scintillating.
Yeah,
So
ma'am.
we have with us,
I do
Madam.
have a similar memory. Like when I was doing my 8th standard, that is the first time I was seeing the launch of a sounding rocket. That time I was just praying, it is just above my head, whether it is going to come back or not. So we were on the seashore. We students were all sitting there, and after that, we have been taken to VSSC and seen that this computers and all for the first time, first generation computer we were seeing. And it was really very interesting how the networks about networking and all was there at that time. And we were really, okay, oh, this is something big we were looking at. And,
indeed. Great.
Yeah. But you please do come to VSSC here. A space museum is there. It is really, definitely it is, don't miss such chances. Please do come at least once.
And Tulika ma'am, what you mentioned about, we have with us Charu Jindal ma'am from a very special school nestled in the Himalayan hamlet of Ranikhet, and very close from Ranikhet there is a space observatory, what we can say, for the common populace. It's run by a group called Starscapes, and they let you watch the entire sky with a very heavy telescope, and you can really fall in love, and it can be a kind of education to the students at large. I would like to welcome Charu Jindal ma'am to speak a few words and what all space activities, and any questions to Rekha ma'am over there, please. Yeah.
Thank you so much, sir, and good morning to all. It's very nice pleasure attended this meeting over here. And so actually, after Chandrayaan 2 also, our student made a project on Chandrayaan 2. It was not a much working model, but the students were very crazy to make this, and they made nicely. We presented in the exhibition. And now all of our students watched the Chandrayaan 3 this time together. And we will look forward more.
That's the spirit, man. So I really congratulate you for the Chandrayaan 2. Failure is not ultimate, and through that we are learning. So this is the message we should give to children. That is, nowadays I think our youngsters, no, they cannot afford any failure and they cannot afford any setback. Such a trend is there. But that should not be the case. And ISRO is the best example that every time through failures we are learning and we are improving. So, and as Chairman well said, through the failure is the thing which is giving the maximum information about our final target. Because real time we are never testing it. For the actual mission we are never doing. So the data we are getting out of real mission is very valuable and tremendous. So that way, similarly, the approach of life also must be like that.
Yes, sir. Definitely.
This is the Ashok Hall Girls
Residential.
Residential School in Machkali, a very special school from the Birla Group, and it's only for the girls. And that's the special ode to the SRI Shakti, Matra Shakti, what we have out there. And Madam said very, very rightly that ISRO is again an exemplar in imparting life skills to our youngsters. So rocket sciences are fine, but you can learn a lot of life skills from there.
Of course, sir, our visionaries told this is all for the mankind only, for our improvement only. So like you are striving for the Atmanirbharta, like this is what space can contribute, and ultimately it all is for the welfare of the human.
So we have yet another school from Delhi, Priyanka Saraf ma'am from Vidya Bharati School, Rohini, Delhi. Rohini is one of the nakshatras, and so located in that nakshatra of Rohini, I would request Priyanka Saraf ma'am to also speak a few words, and if she has any questions, she can ask Rekha ma'am. Yeah.
Good afternoon, everyone, and very, very congratulations to Dr. Rekha ma'am, please, from ISRO.
I am just standing as a representative of ISRO. I shall definitely accept it on behalf of our whole community.
And to the entire team and to the each and every Indian available. Thank you so much. And it was really a very proud moment and a very to the point and important discussion. Thank you so much. It was very much enlightening. I am not from physics, but biology, but still ma'am has clearly, depicted so many things that made me understood it from the ground level. And an important aspect as well, how to implement and to, enlighten the students about this particular space research topic, because physics, they know the basic concepts they are knowing, but their focus or their inclination towards the space rockets, that is to be focused more upon. And so such numerous ways like has been discussed here. Definitely that has, enlightened me as well. And I'll definitely take up this in near future and will make up some club here and will definitely associate with some organizations to enlighten this with among the students so that even they can, focus their career towards this particular aspects of physics. Thank you so much. That was really very enlightening for me. And okay, Chandrayaan 3 is
inspiring them. Do more, please.
We are very much with you.
Yes, ma'am. Sure.
We are very much with you.
Surely,
and
ma'am. Even I am very keen and eager to organize some workshop or visit to such institutes, so that is going to, give the students the first-hand impression about how the things work.
Do join in the Space Week, and we'll be sharing communications with you and collaborating with ISRO and how better we can take this forward. Yeah.
And with humble permission from Rekha ma'am, I would like to say that to Priyanka ma'am, that space is not just about physics alone. It's the convergence of all sciences, and biology is the core of it all. Like, is there a life on moon?
Yes, sir, truly.
So it's the convergence of all sciences, and probably this is an opportunity for the entire STEAM faculty to have a space hackathon, a kind of a space lunch on a Saturday, to find out innovative means and mechanisms on a Saturday lunch if your school opens up over there, and bring out synergies from various topics, various subjects, because now it is the age of convergence, and ISRO has proven, it has shown phenomenally as to how a organizational effort has been so very instrumental in, I would say, a historic feat out there. And I think we come to the close of this roundtable. We have taken so much of so valuable time of Rekha ma'am, and she would be really pleased if this effort really goes on to ignite, catalyze this propulsion, a kind of a space education movement in the country. And as she said very humbly that email is just enough. And we can say that we just wrote to her, and so enthusiastically on a Monday morning, she is there with us. She was there from the very beginning, where we are all waiting for you to join in. So this is the whole set of activities. We would request, we have given you the WhatsApp group link on the chat itself, the Vikram Sarabhai Space Club, what Rethink India would be running. Every Saturdays, we would be trying to have some or the other exciting activities around space. And it will all converge into this Space Week commemoration from 4th to 10th October, where on 10th, we will be having the felicitation of all these activities. So every Saturday, we would try to build up this momentum and try to bring in various luminaries from various walks, popular movies, docu-series. We will try to become an interface, as Madam has mandated us to do. She is sending Gaganyaan. We will be doing the interface of education from Rethink India platform. So I would request Dr. Surbi to give the vote of thanks and any closing words from Rekha ma'am, and then Dr. Surbi, please.
Sir, keep inspiring people. You can do a lot. I am telling you, say more than urban area, definitely I think people can contact. And as I told, one email, and I can always share contact points and other details if you would like to. And this is what we can do for children.
Yes, ma'am.
So yeah, even for rural area also, for rural area also, we can definitely plan what is that, activities. And we can give them tasks. Similarly, this space clubs will be good. Their reports, and when students know they are appreciated for the work they are doing, they will do more definitely. That is children. So you can plan things like you will be taken for a trip if you are doing this, that, and all. Excel competitions can be through your WhatsApp group. Also, you can among the different space clubs, competitions can be conducted. All those things can be done. It need not be always on ISRO platform and all, but we are always there to support you people. And
so see reassurance,
space on wheels and all. You can see that this Azadi Ka Amrit Mahotsav site also in ISRO website. It is one part, and here exhibitions are there. That is 75 major achievements of the ISRO is rolling on wheels. In fact, a vehicle, and that is actually from major 6 centers. It started, I think, in 2022. This was there when we were celebrating the birth anniversary of Dr. Satish Dhawan. And similar things can be arranged now also. I think it is possible everywhere. I'm telling that it is not concentrated at some places like headquarters or Bangalore or Trivandrum or something like that. It's there everywhere. SAG, Shillong, all such places it is there. So locally also workshop can be organized, all those things, and if required, ISRO personnel can come there, and we can help you. All these things are possible. So you may plan things, sir, and we shall interact and see, and we can make it much more beautiful. Thank you so much for this opportunity. I have shared my views. There are many great persons in our institutions, and through interaction, definitely you are going to benefit out of all those. Thank you. Thank you so much.
Thank you so much, ma'am. And on behalf of Rethink India, I thank all the school representatives, honorable school principals, faculty coordinators, and all who have joined us from YouTube and who are watching us live. This is to commemorate the success of Chandrayaan-3 and thanking Madam Rekha KR, Honorable Deputy Project Director from ISRO, to have joined and graced this occasion and address the schools. We hope to take this space mission in the school education and in scintillating the young minds, and to encourage and empower them more and more, to enthuse them, to engage them, and to give them that experience. And looking forward to all of you joining us in the Space Week. Be a space student, and also join the WhatsApp group, the Vikram Sarabhai Space Club group, and with guidance from ISRO and our school members. You're all welcome, and let's take this forward. This is the spirit of it all. Jai Hind.
So maybe at the end, let's have a group photograph of everyone who has stayed us for all this 1.5 hours, and we close this roundtable. So anyone else who wants to come in, just please, Dr. Sanjay Bhattacharya, Ritu Nohoria ma'am, welcome you. So thank you so much. And this is just a very humble beginning in space education from Rethink India. And as ma'am Rekha KR ma'am has given us the mandate, the inspiration, we would be really dedicating ourselves to be the interface between the stellar space programs at ISRO and also linking the school education, the NEP 2020, which is really, which Dr. Manjul Bhargav came up with that infinitum symbol of the Mobius strip. So the NEP 2020 Mobius strip and the spirit of ISRO, I think they all conjoin, and we will take this, we will continue engaging with you all. Thank you so much, Rekha ma'am, and thank you all the participants. Let's charge up our schools with space, क्योंकि भारत का नाता अंतरिक्ष से, व्योम से, अनंत काल से रहा है. हमारी सभ्यता बिना अंतरिक्ष के, बिना सितारों को देखे वो चलती नहीं. तो क्षितिजल पावक गगन समीरा. These have been the 5 elements, while West was struggling to find that 5th element. Gagan, the Akash, the Vyom, Antariksh was always in our consciousness. So with this, we will continue the infinite spirit of our quest for learning. India, which was always a knowledge civilization. So that quest will be on and on.